Yay! Okay. Let me just adjust that. There we go. Hey, Pamela.
Hey, Fraser, how's it going?
Good. So we were just about to record, and we had to take a week off for various holiday slash well, mostly holiday-related
We
reasons.
were on airplanes.
Yeah, and you had prepped this week's show, but hadn't prepped last week's show, which we had
Not
we were supposed to
recorded.
do. Skipped. So we're gonna do this week's show, and then we'll do last week's show next week.
Next week.
Yeah. So if you thought that you were going to hear all about Jocelyn Bell Burnell, I'm sorry to disappoint you.
Next week.
Next week. So we're going to handle Margaret Geller today, which will be great. How's it all going? I hear ice is falling from the sky where you live.
Ice. It stopped finally. About 10 a.m. this morning, ice stopped falling from the sky, but it was one of those mornings where I woke up to the news came on and it was accident report after accident report after accident report, at which point I turned off my alarm and decided I wasn't going to leave the house and snuggled back under my blankets for an hour. It was just that morning.
We were driving. I'm down in the States right now, and we were driving through Texas. I got to experience a U.S. Thanksgiving for the first time, which was a sight to behold. Sweet potatoes with marshmallows on top.
Yeah.
What is up with that?
Did it have walnuts as well?
No.
Needed walnuts. You were not given the full effect.
I was robbed, but a lot of butter was brought to play in this dinner. Anyway, it was very different from Canadian Thanksgiving.
And with my Canadian husband, we actually decided to just have green chili stew and watch superhero movies all day.
Oh, that sounds great. That is a traditional Canadian Thanksgiving.
Green chili stew?
Green chili stew and superhero movies all day. Yeah. Yeah. Cool. Okay. So I guess we're gonna get cracking. We'll move on. Now, one little point of order. I guess two little points of order. If you have never experienced this before, you're about to watch a live episode of Astronomy Cast. The viewership's a little down this week, and that's because we moved it to a new location. So in the olden days, I used to host everything on my personal feed. But now we post them through the Astronomy Cast page. So now there's a YouTube channel on just for Astronomy Cast, and so all the videos should be starting to get posted there, which is going to we'll keep things organized in the future, but it's going to give us a terrible library headache coming up for somebody.
It's going to get fixed. It's okay.
Yeah, but it's just going to be a lot of work. Anyway, so that's going to be our future.
And if you want to volunteer to help us with our YouTube dilemmas, we could use a volunteer.
Yeah, or like some Python script that'll just suck videos from one place and move them over to this other place using the YouTube API. Anyway, so all of the YouTube videos will now be on the Astronomy Cast YouTube location, and we're going to try and collect all of our various things into a channel, but this is just too far in advance. The other thing to just keep in mind is you can talk to us if you wish. You can use the Q&A app, which I hope is functioning. It is functioning.
Okay.
So if you want, you can use the Q&A app. It should say that Astronomy Cast is interacting with the audience, and you can click and you can watch the video and you can post any comments that you want, and we'd be glad to do that. And the trick here is that we'll do the video, we'll record the show, and that'll take us about 25 minutes or so, and then when we're done, we will stick around and we will be glad to answer your questions about space and astronomy.
And since it is Cyber Monday, and we should remember to mention this during the show, we have a store set up on Spreadshirt that already has some stuff in it, and I will be adding more stuff to it today as time allows, and you are all encouraged to go check out all of our stuff, and I'm trying to figure out how to get to the URL for this store, and it's driving me crazy. Just take me to the store, Spreadshirt. It's astrogear.spreadshirt.com.
astrogear.spreadshirt.com. Awesome.
And I'll be adding a bunch of Astronomy Cast stuff this afternoon. Currently, it has an Astronomy Cast button and a bunch of CosmoQuest stuff and a Planet Pluto parody shirt.
Wonderful. All right. How are you in the ability to recordness?
That's far easier than the ability to tell people URLs category.
Well, you've had practice. And we'll ask you to do it again in a second.
Okay, so you want me to press record?
I do.
Okay, I'm pressing record. It's recording. Hi, Preston.
I am also recording, although the audio levels are super low.
Do you need to adjust things?
Yeah.
Okay, stopping the recording.
Testing. Oh.
Well, if you get that close to your mic, it will fix the levels.
No, it's not. It's not.
Oh,
so let me see if I can jack it up here. Hold on.
Okay. Move your mic closer.
No, it's the input volume. There we go. Testing. That's better. But still cranked up. Let me stop it and start it again. I apologize, everyone.
And if I appear to be looking everywhere, it's because my Google notifications are going to my phone, which is on the desk. Twitter is above and to the left.
Testing.
Facebook is over to the right, and people are discussing Astronomy Cast all the places.
All the places.
Like.
Testing. Oh, I think this is good now. Okay.
Okay.
I'm probably louder to you as well, right?
No.
No? Okay. Weird. Everything's cranked right up. This could be bad. I apologize to Preston in advance. Okay, I'm ready to press record for reals.
Right mic.
Yep, definitely got the right input.
Okay, I'm pressing record again. It is recording. Hi, Preston. Again.
Hi, Preston. I hope this works. It looked a little funny. Okay. Here we go.
And Fraser's in an echoey dining room. We're sorry.
Yes. Yeah. Astronomy Cast, episode 359, Margaret Geller. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Kane. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good. I don't know if I've ever mentioned this in the show, but to actually say professor at Southern Illinois University, Edwardsville is actually really hard.
It is. It really is.
To rattle that off, I have to slow down and I have to really choose my words very carefully, and I can often flub it up. And that's where I will flub it up. So I encourage everyone in the audience to just go ahead and say that 7 times. Professor at Southern Illinois University, Edwardsville.
So if you want to know the full glory that I have to write into grants, it's a professor in the Center for Science, Technology, Engineering, and Mathematics Research, Education, and Outreach at Southern Illinois University, Edwardsville.
And the director of CosmoQuest.
Yes, and it line wraps.
and it's like visiting professor.
No. Assistant professor is my full. Assistant research professor is my full title.
Right, there you go. That's even more line wraps. Cool. So before we get into this week's show, which is where we continue our focus on some of the most influential female astronomers, we would like to talk about a place where a person could perhaps pick up some swag.
Yes. So as we enter the holiday season, we know that hopefully many of you out there have people in your lives that you love and you want to give awesomeness to. And we have our own small corner of awesomeness on the internet, and that is our store on Spreadshirt. The URL is astrogear.spreadshirt.com, and we have a variety of mugs and t-shirts and sweatshirts, and pretty much everything is customizable so that you can get it in the color, the size, everything that you want. I've put forward my favorite girl cut and boy cut stuff, and we have everything from a shirt that says Explore Planet Pluto Classic, that is a parody shirt of the Coke Classic logo, to Astronomy Cast apparel, to CosmoQuest awesomeness. So please get some good Astronomy Cast nerdery to give to all those you love.
Fantastic. All right, so on to this week's topic. Margaret Geller is best known for her work on the large-scale structure of the universe, helping us understand the large clusters, superclusters, and cosmic filaments that matter clumps into. And before we dig into this, I actually just posted something on Twitter that was so cool. It was like what the universe would look like if we could see dark matter and talk about filaments. Like, it just looks
Yeah.
like neurons and like spongy thread connected together. And this is the kind of stuff that Margaret Geller helped us figure out. So who is Margaret Geller?
So Margaret Geller is a female astronomer who is at the Harvard-Smithsonian Center for Astrophysics. She got her PhD from Princeton and was actually one of the first women to do that. And she has spent her career basically trying to figure out what is the environment in which galaxies reside, and how do we trace out this larger scale structure of all of the galaxies that turns out aren't quite so evenly distributed as we might have once thought.
So before Margaret Geller did her work, what did astronomers think the universe was structured like?
Well, we were getting the idea that there are clusters and superclusters, but we kind of thought that there was this variety of different sized structures, but perhaps it was just kind of evenly distributed, kind of like a fractal pattern of, well, here's small galaxies, here's big galaxies, here's groups of galaxies, but we weren't entirely sure. And it actually took Margaret Geller and a variety of colleagues across many different years working on a variety of different surveys to finally start to realize that our universe is kind of shaped like Swiss cheese. And the first diagram to really, well, to be unintentionally punny, to bring this to light, was the Geller-Hooker diagram that came out, and it showed the redshift of galaxies on the axis going out from the center, and then it traced an arc across the sky. So what happened was John Hooker, who was a great observational astronomer, went to the telescope and, using spectroscopy, measured the rate at which galaxies are moving away from us here on Earth, and took into account the motion of the solar system, the motion of the galaxy, all of that, and figured out how these different velocities related more or less to the position of these different galaxies. Putting that together got this really neat diagram that actually has what looks like a stick figure dude kind of centered in the bottom of it. And that stick figure dude is the Coma cluster. And it turns out that the motions of the galaxies within the cluster stretch out the cluster into a stripy bit. And all of the rest of the structures slowly are, in this first diagram, just tracing out this lace of structure. Over the decades, they've taken more and more and more redshift measurements and pushed out the distance and the density of galaxies that they've measured, and discovered the Great Wall, a large wall-like structure of galaxies, found more and more clusters, and found more and more voids, and realized it's not a random distribution. It's actually a very purposeful distribution of structures.
It's interesting of the way you've chosen these people. You know, I'm sure you did this on purpose, but how sort of the dark matter discussions from Vera Rubin, with the stuff we talked about last week, more about sort of the some of these large-scale structures, the great attractor, things like that. And it's the same concept about how you've got these large-scale structures which are all kind of related. The dark matter is the thing that's sort of organizing and harnessing them together into these shapes, and the expansion of the universe is creating these voids and filaments, right?
Well, what's been really interesting is with each of these different women whose work we've been choosing to highlight, these are women who made discoveries that required long-term, year-after-year, careful consolidating of multiple results to aggregate an understanding that couldn't come quick and dirty. It required long-term detailed analysis, and they did that needed long-term work to build a completely unexpected understanding of our universe. So,
go ahead, sorry.
So they essentially saw hints of, well, I was trying to study this one thing, but realized there's something deeper going on here. And they did the research necessary, in Vera Rubin's case, to figure out there was dark matter affecting the rotation rates of galaxies. With Margaret Geller, to realize that galaxies are clumped and there's voids, and to figure out what that physically means and how this all relates back to the Big Bang. These are long-term studies that are just literally change how we see our universe. There's no other way to put it.
Right. So let's talk a bit about Margaret Geller then. So where did she go to school? Where did she sort of get her training?
So she as I said, got her PhD from Princeton. She got it in 1975 in physics. She was one of the first women to do that. Previously, she'd gone to the University of California at Berkeley, again getting a degree in physics. And from there, she went on to the Harvard-Smithsonian Center for Astrophysics. And in 1980, she got appointed to Harvard College's astronomy department in a tenure-track position. She was in that position for 3 years, and then she actually left the tenure track. And while she's never come right out and said it, a lot of people have said for her that the reason she left was because of the amount of harassment and backstabbing and snarky comments that she had to face day after day after day while she was at Harvard. And when you're told enough times you'll never get tenure because you're a girl, well, it's easier to say, I'm just going to step back and be a research professor or a research scientist. If you're on the tenure track and denied tenure, you're given 1 year to find a new job. You're out. You're gone.
Wow.
But if you instead step back and fall into a research track, which is what she did through the Harvard-Smithsonian Center for Astrophysics, you have a position as long as you can find funding for yourself. Now, the weird thing about this for Margaret Geller is here's a woman who literally changed how we view the structure of the universe. She has gone on to publish lots of papers, over 125, and I stopped counting. She has received the MacArthur Genius Grant. She has become a member of the National Academy of Arts and Sciences, Fellow of the American Physical Society, award after award. She's one of the top in her field. And she actually has the appointment of a full professorship, or she did until she resigned it in '99. She was appointed a full professor without tenure at Harvard. And she was offered a extremely important, well-funded, named chair. This is one of those things that you only get when the university basically says, hey, you're awesome, we're going to keep you. It was the Mallinckrodt chair. But they said, we'll give it to you, but we're not going to give you tenure. We just won't. And she was the only person to ever be offered that chair and not given tenure. And she actually neither said yes nor no to that position. She dug her heels in and said tenure. And
why not, if not?
And so that offer came in '97. In '99, it became clear that tenure wasn't coming, and so she resigned her professorship at Harvard to strictly be a senior research scientist at the Harvard-Smithsonian Center for Astrophysics.
Right. And, from the reporting side, a ton of what we do at University Today comes out of the Harvard CFA. We get, probably a couple of stories a week are coming out of Harvard's Center for Astrophysics. There's tons of really breaking news coming out of there.
And it's a complicated situation because Harvard is known as kind of being a cesspool for gender harassment. When I was there, I knew of a woman in physics who was asked to document how many hours a day she spent with her newborn because there were complaints that she was actually using the maternity leave to get ahead on her research, which was considered unfair. So she had to document that she was spending enough hours with the child for it to be considered maternity leave instead of maternity leave or just extra time.
Right, research.
Yeah.
Right.
And some of the things that you experience and are told, it just gets exhausting. And I can fully understand, having experienced things like this at many different places, why Margaret made the decisions she did. And I have the utmost respect for her basically saying, you're offering me this amazing opportunity, but you're putting strings on it. And I'm not going to roll over and accept this prize with your strings. I want this prize only if you give it to me the same way you've given it to everyone else.
Right. So I guess, is that where she currently is then?
Yes, she's currently at the Harvard-Smithsonian Center for Astrophysics. This makes her a civil servant. It means that her funding comes predominantly from grant research, that, like me, she's in jeopardy of, and this is why I feel for it, is I have the very similar position at my university of being in a research center, which means no matter how good I do, the second I don't have enough grant money, I'm out of a job. And this is something I'm currently facing.
Right. You're always writing grants. You're always looking to try and acquire money for the projects that you need to work on, because that's what makes the whole machine run.
Right. And universities really benefit from having research scientists. People in these types of positions, you bring in all of your own salary, you bring in money to fund people to work with you, and then the university also takes a percentage off the top. The percentage varies from institution to institution, anywhere from a few tens of percents to actually requiring you to bring in more than twice the amount of money that you need, and they'll take half of it. And so the money that you bring in benefits the institution, allows it to build new buildings, hire support staff, all of these different things to keep the light on, the heat going, and fund students, and fund computers for other people, and do all of these other things that keep the institution going, while the institution makes no promise to you. And at any moment, you can be out the door. And for her to say, you know, this is where I'm going to stick unless you give me tenure, that's a brave thing, because a named chair like the Mallinckrodt chair, it does come with money. It does come with a certain amount of security that helps. And she said, no, I'll take my lot as a research scientist.
So what else has she worked on? She worked on, obviously, this original work back in the 80s of large-scale structure of the universe. You mentioned the Great Wall. What is that exactly?
So if you look in one direction across the sky in what's called the first Center for Astrophysics redshift strip, that's where you see the stick figure dude. But when you look at the stick figure dude, you see coming off of his arms this kind of wall of galaxies. And as you continue to look at fainter and fainter galaxies, that wall gets thicker and thicker. And as you go to higher redshifts, you realize that wall has nothing on one that appears at a more distant redshift. So our stick figure dude, he's at a redshift that translates to moving at 10,000 kilometers per second. The Great Wall is out at 10,000 kilometers per second and spreads out all the way from 16 hours to about 9 hours of right ascension across the sky. And it's kind of awesome, and we'll include pictures.
Well, I mean, we always talk in terms of like arc minutes, arc seconds, but you're talking about arc hours.
Hours.
Here. Yeah. So that's a big chunk of the sky.
Yeah. And it starts to fade off at about 9 hours, and what's really cool looking at it is at about 16 hours there's this long spiky bit coming off of it, and that long spiky bit is another galaxy cluster where the galaxies are moving so rapidly in the cluster that they spread out in this long finger. These are sometimes called the fingers of God in the redshift space.
Now, are these part of the Virgo supercluster or way farther away?
Sorry, I have to look at this map to see which is the supercluster that's at 16 hours. Sorry, Preston, you're going to have to edit this so I can answer the question. It's not telling me what cluster is the one at 16 hours. Are you going to tell me?
I'm not going to.
No. I just scrolled to a different part of the diagram.
Oh, okay. All right. Just because that's a structure that supercluster that a lot of people know about, right?
Right. So the finger, not the finger, the okay, so it's the Virgo cluster. Okay, so I'm going to now answer the question, Preston. I'm so sorry. So looking at this, the stick figure guy, that's the Coma cluster, and one of the other fingers of God in this diagram is actually the Virgo cluster. So we're picking up a couple of different massive clusters of galaxies and this wall that just extends all the way through this particular strip. So the one that really makes the wall start to stand out is the Center for Astrophysics 2 survey, and it's the first 6 slices put together that allows this all to stand out. And we'll put pictures of this in our show notes.
And I was looking through Geller's biography, and she also is the co-discoverer of hypervelocity stars.
Right. That is something that, because I don't do that field of research, I totally forgot about.
Yeah.
So hypervelocity stars are stars that get ejected through a variety of different interactions or supernovae explosions, and are basically these runaway objects that you can measure across a lifetime how they move across the sky, and that's kind of cool.
Yeah, absolutely. Like you can have like a 3-body interaction, or you can have, as you said, the supernova going off and detonating, and the blast kicking a star out of the entire galaxy, which is pretty crazy. Cool. Okay, so what else should we know about Margaret Geller?
So she took things from just doing the initial maps of the one-dimensional or two-dimensional rather slices through the universe to building complete 3D maps, and her work led to some of the very first renderings that people saw on TV shows and in planetariums. She did an 8-minute video in 1989 called Where the Galaxies Are that created a voyage through this large-scale structure, and actually was awarded the signed Gold Eagle Award. She went on to do a 40-minute film called So Many Galaxies, So Little Time, that won awards for its graphic renderings from the IEEE and SIGGRAPH. And it was on display at the National Science Museum, or National Air and Space Museum. So here you have a woman who does amazing science, who is doing hard, complicated work, detangling redshifts, figuring out spectra. This is all observational work, and then you have to figure out what theories match your observations to try and explain everything. She's working to make sure her results get published in the top peer-reviewed journals, and make sure that they reach out to the public through accessible videos and easy scripts. She's given lectures all over the world, and she's even on the National Public Radio here in the United States, their list of best commencement speeches ever. So she's a woman who can communicate.
Right, and that's really, really important. I mean, I think that was Carl Sagan's magic, and a lot of the people like right now we have Neil deGrasse Tyson. But I think where Neil is really great at explaining things, Margaret Geller did the research, understood the implications, and then helped get them simulated in a way that regular folk, the public, could wrap their heads around. I guess a really good recent event like this is like what happened with Interstellar, right, where Kip Thorne helped lead the simulation of the black hole, Gargantua or whatever, in Interstellar with such a level of precision that it both looked beautiful and had some useful scientific understanding for research. So that's the magic. If you can take these what are just numbers, right? I mean, these are just right ascension, declination, redshift, what kinds of composition the galaxy is, and turn that into a 3D rendering that shows you what our local neighborhood looks like. That really helps put things in perspective. So I mean, that's some of my favorite. When people do that, I'm really excited.
And one of the things this actually articulates indirectly is one of the reasons often given for why she doesn't have tenure is, well, she's cranky, she's difficult, she's grouchy, she doesn't work well with others. But then you look at the body of her work, and she's had collaborations that lasted decades. She's worked with people from a whole variety of different backgrounds. And when you see the range in working with top scientists and top creatives in projects in the private sector, and she's given multiple talks at the Choctaw Institute, which is an indigenous peoples institution. Clearly this is someone who does know how to collaborate, and it's the irascible professor put it very well in a blog post, where he says, I can imagine that something like the following discussion must have gone on in these hallowed halls of Harvard University when the issue of tenure for Geller was being discussed. Professor Y, and we've already promoted her to full professor. Shouldn't we make it official by granting her tenure? Professor Z, but she isn't exactly one of the old boys. I don't know if she would fit in over at the faculty club. And besides, there's just no evidence that she's able to walk on water. I mean, this is a woman who's done amazing things, but
she can't walk on water, no tenure.
Exactly.
Yeah. So then, I mean, she's still an active astronomer right now, still a researcher.
Yes.
And this is, her career is not over. So what's she working on, like, right now?
She's part of the Sloan Digital Sky Survey team. So when you see those amazing new renderings that allow you to fly all the way out to the cosmic microwave background radiation, she's one of the people in that collaboration that is taking our understanding that started with this one narrow slice that showed Coma clusters, stick figure dude, to now doing this massive wedge through the universe that is allowing us to test models that show how our galaxy's structure has evolved from the cosmic microwave background to today. And that's just awesome.
Yeah. And then she's working on a project called Shells, which is I've got the Astro PH, the Hectospec Lensing Survey, which combines a large, deep, complete redshift survey with a weak lensing map from the Deep Lens Survey. So I guess this is dark matter lensing distribution matched with a redshift survey.
And this is adding the dark matter component to the luminous matter component, so that you can start to see how is it that light matter does, and in some cases doesn't, trace out the dark matter by looking at how the dark matter leaves evidence of itself by distorting light passing through it.
And I mean, there was some great research that just came out just within the last couple of weeks about how quasars line up strangely within these filaments of dark matter.
And that sort of makes sense if you think about it in terms of quasars trace out galaxies that are undergoing massive star formation in some cases, undergoing collisions, all sorts of activities that happen more in the early universe. The dark matter is the places that where it was in its highest density, it pulled the luminous matter in. So the luminous matter flowed in to this dark matter scaffolding, started forming structures, these structures interacted. Those structures were the first galaxies, and those galaxies were interacting in these filaments of dark matter that allowed all of this material to be drawn together.
So one thing I just did here, I just put her name into AstroPH, into archive.org, the astrophysics, and for her name, and she's in 118 papers. And that's just ones on AstroPH.
Yeah, that's
right?
actually low. So
no, that's not all the papers. These are just like the ones that came out since AstroPH was keeping track of them.
Right, exactly.
Yeah.
And
that like 4 years maybe is what I think it's about.
So the number that I found was in 2001. She had 127 published articles since 1982. And then there's been like another 100 since then.
Yeah. And so just 100. So that is she's a very prolific researcher, which is just amazing. Yes. Cool. All right. Well, thanks a lot, Pamela.
Thank you.
All right. Just need to save this.
Yep.
Come on, save.
And then we'll look at all of the questions that went flying by.
Oh, can you dig them up?
Trying to figure out how to put these. Okay, there are things in a language I do not speak. To the person posting in French, I don't speak French.
Je ne comprends pas.
Nancy Graziano says that it's warm in Jersey. She used a dash to say 65 Fahrenheit. I'm going to guess that dash 65 Fahrenheit is a dash and not a minus sign there.
Minus 65, that would be pretty scary.
Yeah, yeah.
Alex Hugo Burnham says, so it's now last week. Anyone have the lottery numbers? You're time traveling now.
And Hugo Burnham is asking if the store delivers internationally. I believe that they do. We used to host our own store, and I personally shipped things all over the planet, and realized that life is too short for me to spend a lot of it at the post office. So I'm outsourcing. It says that they use UPS in the United States Postal Service. That doesn't give me a lot of information. Clicking around. Yes, they do international shipping.
Cool. I don't see a lot of questions. And if I don't see questions, that means I have to come up with complicated questions.
Oh, dear Lord. Okay, so Hugo Burnham asks, how did the cold dark matter of the Great Wall attract the baryonic matter that we observe in such a short time? Short is a matter of perspective. It works. That's not a very satisfying answer, however. If you use a lambda cold dark matter model, you can recreate the observed formation timescales. If you use just a cold dark matter model, you don't get there. It needs to be the combination. And a hot dark matter universe gets things forming far too fast. So it actually works. Short is in the eyes of the beholder.
Cool. Short. So next we're going to do a show on Cecilia Payne.
Right now we're just doing people who are alive, because I noticed that there's a whole lot of stuff out there that highlights women like Cecilia Payne and Carolyn Herschel and all of the Center for Astrophysics, Harvard College Observatory women that worked for Pickering at the beginning of the last century. Cosmos highlighted a lot of them. But when it comes to amazing women who are still doing amazing things, these are women who are fighting for their careers every day and not getting highlighted. When I saw names getting tossed around for who should do the next season of Cosmos, the names I saw were all men. Why not nominate Michelle Fowler, who's done amazing work in communications, working at NASA and the Jet Propulsion Center? Or Jet Propulsion. Yeah, there's so many women out there.
Or you.
I would love to do it.
Yeah, you take the job? All right.
I would take the job.
I'll put in a good word for you.
Yeah.
When they invite me to do it, I will pass and send them your name instead.
I cried a little bit when I saw that there were people recommending Michio Kaku. That just hurt my soul and my desire for
Well, that's what I've heard. That
science.
he's most likely, right?
Yeah, I think the show will lose a lot of credibility if that happens.
Right. Well, I think now is the chance. Everybody who's watching this, begin your letter writing campaign. Pamela should take over Cosmos. Neil deGrasse Tyson, I'm sure, would say nice things about you too. So you know each other. You guys are thick.
I wouldn't go quite that far, but we do know each other.
You know each other. You guys have met. I think you introduced me to Neil at a LA one year.
Yeah.
Before he was super famous, when he was just regular famous.
He gave me some career advice early on, and was one of the people that really opened my eyes to how harsh and judgmental our world is.
Yeah, he's had to deal with, I'm sure, all kinds of issues of his own from a race standpoint. So.
I will never forget, he and I went on stage along with Lawrence Krauss and Bill Nye, and we were told the two of us needed to sit in the center of the table so we wouldn't look marginalized.
Right. Never ends.
Yeah.
That's the classic. That's of course the shush heard around the world.
I just wanted to make my point. That's all.
Yeah, I know. So if anyone wants to dig that up, I highly recommend you do a search for Pamela Gay, Neil deGrasse Tyson, Bill Nye, Lawrence Krauss, and you will see a hilarious moment where Pamela stops the two guys from just rolling over again. It's classic.
Well, to be fair, it wasn't just that I was the only girl at the table, but I think the three of them bracketed both sides of my dad's age. So
right. Phil was moderating that, wasn't he?
Phil was moderating it, and I think the poor man had no hope.
There's a lot of personality going on there. Yeah, absolutely. Okay, well, I think I don't see any more questions. I think probably.
Your video froze. You are no longer moving. I hear nothing. Hello.
Can you hear me?
Now I can, but okay, your video is sort of catching up. Okay, now you're moving again.
Okay. Okay, Guido Bieber says that Cosmos should be co-hosted by Neil, Pamela, Bill Nye, and Emily Lakdawalla. Period.
I can get behind that combination. Emily would do an amazing job, and
Emily Lakdawalla would be terrific. Yeah.
She has this poise that must come from having multiple small children.
Yeah. No, Emily is fantastic. Yeah, I don't know what I would do, Pamela, if they said you or Emily. I don't know. Maybe you guys.
Emily would be better on camera. I'm better on microphone. And
there you go. Yeah, you do all the voiceovers, and Emily will do the on camera stuff. Perfect.
She works from home and has developed this amazing poise, and it's so cool to watch.
Yeah, we actually interviewed her for a bunch of the videos that we did on YouTube for our Guide to Space. We've got a bunch of interviews with Emily, and they're just terrific. She's just so knowledgeable, and and she really, boy, did she dominate during the Philae landing. Like she went there and she just did the high, like there was no you didn't read anything else but Emily's Twitter feed during the Philae landing.
Well, and it's not that she's just knowledgeable, but she knows how to communicate. She is this calming voice. She knows when to let the snark loose. She brings creativity into it with a variety of different side things that she does. She's this rounded individual who does a lot of things without being frenetic about it.
Yeah, absolutely. And she actually did a great series of videos on Planetary Society just about what was happening with Curiosity, and I was able to sort of be her sidekick for a couple of these episodes, and I mean, it was just a total honor. So anyway, Emily Lakdawalla for president is all we're saying. Cool. Okay, so Pamela, thank you once again. Thanks everyone for watching. I'll be back in Canada tomorrow, but definitely for the weekly Space Hangout on Friday. I'm hoping to have a special guest. We'll see if I can pull it off. If not, then the week after that. So we will, and we'll see you all next week.
Sounds good, Fraser.
See you later, everyone.